Karen. I wanted to make a video so that I could make a little bit more sense of the spreadsheets that I'm sending you. So I'm going to use the integrated spreadsheets. There's 3 of the peak and 3 of the integrated, but I'll just go through one set for an example so you kind of know how I did my step-by-step process. The spreadsheets that are marked as integrated SPSS sheet use or peak SPSS sheet use were the original data sets that we started with. And what I did is I just popped in subjects 4 and 18. And then similar to what I had brought up during our meeting on Thursday, I have the skewness and kurtosis calculations as well as the outlier boundaries that I told you about. So what this spreadsheet is designed to do is in these columns there's conditional formatting that will highlight any values that are above the higher bound. I didn't really worry about the lower bounds unless, I made sure those were highlighted with a red box if they were not a negative number, but most of the lower bounds were negative, and we know we're not going to have any negative percentages. So pretty much all of these are going to have boxes that highlight numbers that are on the extreme end, on the high, or extreme high end of the distribution. But basically what happens with this is these calculations are based on the numbers in each respective column. So the method that I used is I would start with the greatest outlier and I would delete it. And then you can see down here the boundaries change based on the values that are still existing. I tried calculating this, fixing the high bound to when all of the numbers were in, as well as letting it adjust itself, and I came up with the same thing every time. So I'm pretty sure like what we end up with is actually reflective of the shape of the distribution. But I would just delete things from highest outlier to lowest outlier, and then you'll see like other outliers flag up, but once we delete the big ones, the distribution ends up normalizing out. And the way this is set up is if these skewness or kurtosis values are greater than 2 or less than -2, usually we say that the sample distribution is skewed or kurtosed enough that it's not representative of the population, which we assume to be normally distributed. So I was trying to get the numbers that are in these yellow cells as close to 2 as possible if they were on the high end, but if I deleted stuff and they ended up being normal, then I just left them where they were. In some cases, like you can see here, I'm actually going to switch spreadsheets because this is kind of the original. What I did is I copied and pasted this into a spreadsheet that got rid of the outliers. But you'll see here is a good example that at sometimes like the high bound is 5.89, and this is still going to be flagged as an outlier because it's greater than that higher bound value. But you can also see that the values in the skewness and kurtosis boxes are relatively close to 0. So that means that we're basically normally distributed for our samples. So I was trying to maximize the sample size such that we still had a fairly high number of pairs to run through the stats, and if there were values that were close enough to this the outlier mark and they didn't negatively affect the distribution, I just kept them in. The other thing to note on these is if the cells are not red, or if they are red, I tried to get these numbers, if they were on the high end, I tried to get them as close to 2 as possible. And in some cases, like for this one, I can't remember if it did bad stuff, but you can see the skewness value is 2.07. If I tried to fix that by taking out the next highest outlier value, it actually increases the skewness number. In some cases this happens, in other cases it doesn't, but I think it kind of just depends on the numbers that are in the distribution. But if I kept doing that, you'll see like the sample size we have is 18 and it's relatively normal. But then if I, kept taking out numbers until I had 2 yellow cells for that skewness and kurtosis values, it ends up giving us a sample size that's ridiculously low. So there are some values in the omitted outlier tables that are going to still be flagged as red and outside of the limits that I originally set, but they were close enough that I thought it wouldn't be an issue. So from this table, I ended up, SPSS didn't like the percentages, so I just converted everything to regular numerical format. And this is the actual table that I put into SPSS. So if you wanted a reference or wanted to run stuff on your own, this is the table you would use. I'm also including the data sheets that I used in SPSS, so I mean they already have this stuff in there, but just in case. Okay, the other thing I wanted to point out on this is that I have the sample size calculated on here, and the way that SPSS processed everything through the t-tests was that, like, say we were doing a standing parallel versus reformer parallel, and standing parallel ended up, when we toss outliers out, ended up having a sample of 18. Reformer parallel had a sample size of 20. What SPSS did is it says if there is a non-existent pair, then it throws that data out. So in the comparison between standing parallel and reformer parallel, it has a sample size of 18 because it kind of tosses out wherever we don't have existing pairs. So that's kind of like the framework on how the sample sizes get generated in my charts and graphs spreadsheet. So this is the next main one and kind of like the ending point of the spreadsheets. And what I did is from the SPSS outputs, I inputted all of the results and reorganized them into a table that was a little bit more reader friendly. And I also formatted it so that if we copied and pasted it into a Word document, it looks fairly clean. So, I mean, we can always change this. The formatting is super easy to adjust, and if you want it a certain way, or if there's certain guidelines to whatever journal you're submitting to, then, I mean, we can always change that pretty easily. But I organized it so that the sample size after outliers were removed and the pair numbers were adjusted. This is the column telling you how many subjects were compared, and then mean and standard deviations for standing parallel versus standing turned out. And then I also noted the mean difference. Through SPSS, this one, and for this example, it was parallel minus the turned out value. So whenever there was a negative mean difference, I just put it in parentheses. And the parentheses obviously would indicate that the turned out value was greater than, or the turnout mean was greater than the parallel mean, which can obviously be seen in the values presented in the table itself. And then any significant differences with a p-value of less than 0.05 are notated with an asterisk. From these, I made, I don't really know what I would call them, but they're kind of auto-generated tables. So the way that it works is that there are cell references to the main table here. So if you keep your eye on this cell, let's say that I delete 2.71, you'll notice that this value then turns to 0% because there's no cell reference. If I put it back in, we go back to normal. So I did it this way. So we have like a basic framework, but if we notice there was a mistake or we go back and decide to do a different method in the future, the framework is there. We just change the numbers. The numbers will automatically change in these tables, and these tables feed into the graph, so the graph will automatically change as well. When I looked at the graph itself, organized, by position, but having the horizontal labels being the muscles, because the tib anterior and the vastus medialis percentages were so much higher than the average percentages of the other muscles, it kind of made it a little bit difficult to see the differences visually. So just in case we didn't want to use those, and we can always change them, I don't really mind. But just in case we didn't use those, I also made charts and tables organized by muscle, and all of these tables kind of in this section are also automated to change when the numbers in this table change. So I thought at least this was like a little bit easier to visually see the jumps that some of the percentages had that weren't really apparent in the other graphs. And what I did is I have like standing parallel versus standing turnout, reformer parallel versus reformer turnout, etc. And then if there were any significant differences between the means, I just put a bracket with an asterisk. So I don't know, I thought those looked a little bit better, but I think it all comes down to how you ultimately want to present the data. So I just use the integrated spreadsheets as an example, but the exact same thing goes for the peak sheets. And then close. Let me see if I can find it. I also added to the stat comparison table, and I'll rename this so that it has the date that I changed it, so it doesn't get confused with previous versions. But I inserted the SPSS t-test results next to the Excel t-test results that you had previously done. The thing to remember is that I don't necessarily know how easily we can compare the SPSS to the Excel test results because the sample sizes are different. I think yours all were operating off of 18 subjects because subject 4 and 18 had been removed. Mine were starting with 20, and then obviously sample size changed as outliers were thrown out. So I notated the sample size over here just as an extra reference if you were wondering, and then I notated the direction kind of similar to how you had, I think it's not on this one, but it's on the peak one that you had, or the peak spreadsheet that you had sent. But I just notated like in general between the means, what was shown is that in this one, like the reformer values were greater than the standing values, p-values are notated here. And if we see something like 0, SPSS runs out of decimals at like up to 3. So if we reported exact p-values, this would actually just be p is less than 0.001. So just a side note. But I inserted these for both the integrated and the peak tables, so you can take a look at those if you like. And I'll also be attaching this is kind of like the list of things that I'm going to send you. I'll also be attaching the SPSS outputs and data sheets. That way you have them. They are listed as no outliers, so that's how they're distinguished from the previous tests that I sent you. I know your SPSS isn't up to date, but I thought it would be good for you to have them, on a flash drive or on your computer just in case, something happens to mine, since we've had stressful issues in the past where data has disappeared. So, yeah, I think the numbers came out pretty good. What came out significant fairly makes sense to me. So hopefully that kind of covered what you wanted me to do. And then obviously if something doesn't make sense, let me know and we can always schedule, another Zoom meeting, or I can go back and change stuff pretty easily. So if you have any questions, let me know. If you want something changed, no problem. Hopefully the video helped clarify what is actually in the email though.